Next up, we have another practical solution, just like in ours. So in this case, we have Klave, and I'm very happy to have Rory with us, who's a senior software engineer at Klave, and he will explain how this works and what are the verification challenges or some problems for verification. Thanks a lot.
So, hello everyone, my name is Rui. I'm a senior software engineer at Secretarium, a company developing Klave. And today I would like to talk a little bit about what we do at Secretarium, what Klave is, and also some of the challenges that I think we all face in the confidential computing space, not only regarding attestation of the confidential computing platforms themselves, but also the applications that are actually running the business logic over the data that we are trying to keep private, and how can we then make this accessible and understandable. So starting with Klave, Klave is a trustless confidential computing platform, and trustless means that you don't have to trust us, you don't have to trust Secretarium, you should be able to verify everything independently. Klave runs on Intel SGX, and it's a cloud platform, and our objective is to make it easy for developers to deploy their applications and leverage the power of confidential computing. So Klave comes with an SDK. It's a TypeScript SDK. We are targeting languages that can be compiled into WebAssembly. Klave also integrates well with GitHub, so if you're already using GitHub to host your projects, you can just give the Klave platform permissions to access your repos, and Klave will then fetch the code, build it into WebAssembly, and then deploy it automatically into an enclave. And so this is more or less what it looks like to interact with Klave. So you start off by just typing some simple commands to get your hello world type of application going. Once you have your repo created, you can then start writing the code. So this is as much code as you need to do kind of a key value store using Klave. You then push your code into GitHub, and then Klave fetches your code, builds it, and deploys it. So we can see on this screen, we have 3 different applications. And we have several versions that have been deployed, as we can see by the different Git commits there. And then when you click on one of these deployments, we will also tell you the state of the platform, so that you can verify that the platform is up to date. We will show a list of security advisories that might be affecting the platform. And we also allow you to download the actual SGX code so that you can verify it against a verification service of your choice that supports SGX. So yeah, that is more or less how what Klave looks like. Now, so let's look at the different types of isolation that we have on confidential computing and also traditional computing, which basically means we have to trust every single layer on the left there, from physical access to the hardware all the way up to the operating systems and the applications running on it. And if there is a compromise in any of these layers, that may result in user data getting compromised. And then on the confidential computing space, we have different isolation techniques. So virtual machine isolation, where the operating system and applications are running in a confidential VM, as is the case of AMD SEV and Intel TDX. We have other techniques like container isolation, something like Scones, for example, I think would be an example. Application isolation, so solutions that create some kind of microkernel to satisfy a number of system APIs, either to implement them in a secure way or to just bypass them to the untrusted operating system and delegate them to the application, then the effort in detecting and mitigating any potential attack. And finally, we have library isolation, which is where Klave tries to be. We try to have as little code as possible running in the trusted execution environment. We have well-defined enclave interfaces so that we know exactly what are the boundaries between trusted and untrusted code. And with that, we hope to basically minimize the trusted computing base, the chance for attack vectors there. And that should also have an impact on the whole attestation process. It should be easier to attest a library rather than the whole operating system and all the applications that are running inside it. And I think lately we have been seeing a trend of projects, including projects that are already running in SGX, to migrate to Intel TBX, for example, and migrate to confidential VMs as some kind of natural evolution of SGX. But I believe it adds a lot of complexity to the attestation process and to what needs to be verified. We have, the kernel parameters, initial RAM disks, bootloaders, all of the applications that might be running inside the confidential VM, the different versions that you might have running in there. And all of these are also expected to be moving targets and to move quite fast. We expect libraries to be updated regularly, either because of new features or security mitigations that need to be deployed. And so we see solutions that are offering confidential VMs highlighting the importance of the attestation process and verifying all the measurements, the golden values as they are referred to sometimes, but there's not a lot of explanation on how can one obtain those measurements independently. And in cases where the service provided might even be closed source, I would say that it's pretty much impossible then for someone to independently verify everything that is going to happen to one's data before sending it to the platform. And so, yeah, at Secretariat, we do not want to leave any gaps where we could insert ourselves as having to be a trusted party. And so we want to make things as transparent as possible so that everyone can independently attest what we are doing. So let's talk a little bit about attestation, just what is the purpose of attestation. So the attestation process is the process that will give a user who wants to interact with a confidential computing platform all of the evidence that a user needs to have some idea of what's going to happen to his data before sending it to a confidential computing platform. So the user needs to challenge the platform and make it generate and produce all of the measurements and all of the attributes, all of the configurations that are running, so that they can be then signed by an attestation key that has been derived from root keys that are part of the hardware trusted execution environment. And then all of that signed data gets sent back to the user, who can then, who then needs to do two things. First of all, it needs to verify the authenticity of that data, whether it has been signed by an actual, let's say, an Intel SGX CPU rather than some CPU pretending to be an enclave. And once the challenger obtains that information, it then needs to actually look into the contents of the reports to understand whether the measurements that are being reported match, for example, the code that is being published as being the code running on the confidential computing platform. Now, in the case of Klave, we are at the moment dynamically loading code. So when we start our enclave that contains the WebAssembly runtime, we then load code dynamically. Now, an Intel SGX enclave is statically linked enclave, and so the measurement of that statically linked enclave will not reflect the code that has been dynamically loaded. And so we need to report the code that has been loaded, for example, by leveraging on the report data field of the Intel SGX report, together with key material that is going to be used between the enclave and an end client to establish a secure connection between an end device and the enclave. And only then can the user be sure of what or which code is actually going to be processing the data that the user is about to send, which is what we then see on the right part of this graph. So what do we mean by following the attestation processing and obtaining these measurements? Like, what are the actual technical concepts that the user who wants to independently verify the attestation, who wants to verify the confidential computing platform, what are the concepts that one needs? So, of course, it needs access to the source code of what is running in the enclave, and so the user needs to have good knowledge of software development, so it needs to understand all of the languages involved, all of the tool chains, whether we are using the correct compiler or a linker that includes a particular mitigation that is affecting a particular Intel CPU, for example. It needs to understand, the user would need to understand build systems to understand whether everything is actually being built from source, and is everything reproducible, or are we magically fetching binary files from binary repos that may or may not be reproducible, for example. The user then needs to understand what the application is. So if we are talking about an application that is trying to verify my electronic passport data, for example, it would be nice to know what kind of information is stored on my passport and what is the code going to do with that data. If it's things more complex like healthcare, if there are hospitals who want to process my medical records and cross that data with other patients, how can I be sure that the outputs of those computations or those scientific researches, can they be traced back to me, for example? Also, digital cash, so CBDC, eliminating physical cash. How can we convince citizens that governments or big corporations are not going to be able to trace every single payment that a person does in a world where there's no physical cash anymore? A user needs to know cryptography, of course, all the algorithms, which ones are appropriate, which ones are now considered out of date. To fully understand all of that, we need to understand maths and where does the security actually come from, what is the difficulty in cracking said algorithms, for example. And then a user should also be aware of computational advances, which means that perhaps an algorithm that is secure now may not be secure in a few years' time. And so the data that I am submitting to a confidential computing platform, is it only valuable now, or should I take into consideration that maybe in a few years, if someone has kept records of everything that I've sent, maybe they can still crack that and reveal something that might be compromising for me as a user. The user, of course, needs to understand confidential computing, and that means understanding all the differences between the different trusted execution environments. We should also prepare ourselves for TEs calling themselves TEs when some of us might disagree, because they are not really in the spirit of confidential computing. One needs to understand the threat model that might affect one confidential computing platform, but not another. And confidential computing is still somewhat of a new field, and even though it's been around for a few years now, you will still find yourself talking to security researchers or security teams within a company whose job is to oversee the whole architecture of the software being developed at the company, or the database administrator, and they still don't fully understand. If they have never been introduced to confidential computing, they will still look at your platform as if it's running outside of confidential computing. And so they may not understand that a vulnerability that is affecting a library might affect it when it's running on the operating system that is running outside of the trusted execution environment, but it might not be possible to do the exact same exploit when running inside an enclave, because the entry points for that attack vector might not be exposed, might not be there. And then we have all the work that is going on with formal verifications, creating the standards, the frameworks, so that developers can probably start doing a better job than they are now doing now regarding proving what their software is actually doing, so that we can start creating an ecosystem of libraries and programs that have been formally verified, and that we can start creating that trust. And all of this needs to be accessible, and by accessible I don't just mean to developers like myself, but how can we then make the results of this great work that is going on formal verifications, how can we make that accessible to someone who might not have all of knowledge on all of these concepts, or potentially none of these concepts that I've just mentioned. So let's look now at a few things that I think we need to look at when trying to verify a confidential computing application. Some of these things are already common with traditional computing. So deterministic builds, for example, this is what we have practice. We already have operating systems with confidential with deterministic builds, libraries with deterministic builds, and in confidential computing, this is of course very important as well, because the objective is that everyone should be able to verify the same code and obtain exactly the same measure. We have things like messaging protocols, for example. So in the same way that I expect my HTTPS connection to be protected with TLS when I'm communicating with the website, if I am interacting with an enclave, I also expect my data to be protected while in transit. And so this is, again, one of those common topics. But then we start diving into properties that are more specific of the confidential computing world. So if I am sending data to an enclave and then that enclave shares data with another enclave, then I need to also attest that other enclave. And if that other enclave is running on a remote platform, then I also need to attest that other remote platform. So we need to start creating a chain of trust. This is, of course, specific to confidential computing. How is the data stored, for example? So in traditional computing, I know that from the moment I submit my data, there's little that I can do about controlling how it's going to be stored. It might be stored in clear text, it might be encrypted, but who holds the encryption keys? I have no idea. And the same thing goes for data migration. What will happen to the data once I submit it? Will it be shared with other applications, for example? But in the confidential computing world, I think there is legitimacy to ask questions about how is the data going to be stored, how is it going to then be migrated, because with confidential computing, we can enforce rules and prevent data from being accessed by other applications or from being automatically migrated to other versions of the same application. So this concern about what applications are doing with our data, this is not a new concern. We have become accustomed to, for example, when downloading an application on our smartphones, we expect to see a description of what the application is doing and what sensitive information it might request access to, like accessing my location or my contact details or my messages or calendar. And we also expect the operating system to play a role in that as well, in alerting me when the application is trying to access sensitive data and actually give me the controls to, for example, block it from doing so. And so this is something that I believe is fairly easy to be understood by most people, even if they are not tech experts. And I think it would be great if in the confidential computing space we could have something equivalent, highlighting not only what the application is doing, but also the sensitive parts that we can protect using confidential computing. So we could have an application running on Klave that has been verified by the experts at the Technical University of Dresden, who have verified that all of my data is end-to-end encrypted from the moment it leaves my device all the way into the enclave, that the enclave is not going to be sharing my data with other enclaves, for example, that the way data is stored is going to be specific to that application or to that application version, and that I, as a user, have control over the data migration process, for example, by having an enclave that creates a silo for my information and only migrates it if I explicitly authorize it to do so, for example. So that's mostly from me. If you would like to discuss about confidential computing, I'm more than happy to do so. If you would like to test Klave, you can register at klave.com and you can message me on LinkedIn and I'll make sure to get you some vouchers so that you can test the platform for free, of course. Thank you for your time.
Just a quick check on the last slide. So you mentioned wait for particular president to be on the same page. So is it based on our discussion that we had once, or is it something else, or is some of my colleagues working on this?
No. I mean, this is just an example that I brought here.
Yeah, but I mean, who has verified and what exactly is verified?
No, this is an example, right? This does not exist at the moment. So what I'm suggesting is that, in the same way that we have people working in academia trying to verify all of the protocols and so on. How can we leverage? And of course, I use the Technical University of Durham here as an example.
Okay. So just to clarify, so what you're saying, it can be verified, but it's not verified. So it's not verified.
No.
So it can be verified in the future.
Yeah, exactly.
Okay.
We are still.
I would be interested in what are have you already thought about what would be the verification challenges, so that would be interesting for us to know. Are you already aware of any challenges that we might face if we take such a verification effort? Do you already know something?
So the challenge on our side as a company, first of all, is this has been a closed source project for a while. It started a long time ago. There's probably a lot of custom protocols going on that even I'm not aware of potentially. And so there are definitely parts of our code base that are still not open source. And there are probably parts that we still need to do a better job at modularizing them and isolating what needs to be attested from what does not need to be attested. So we have code running in enclaves that might matter to us, but that code never sees data in clear text, never sees user data. So it's not really relevant for our users to attest that part. It's only relevant to us. So there is still a lot of work that needs to be done there, creating all of the code separation to make it easier so that nobody is wasting time verifying code that doesn't actually play a role in the attestation process. And then, of course, we still have a lot of work to do, potentially adopting more libraries or more protocols that perhaps have already been formally verified, and perhaps we don't need to be using our custom ones that would need to be verified once again, for example. So we may have to adapt some of our code base for that.
Right. And on one of the slides you were showing, like the slides like 12 and so on. So you were showing like a technical concept. Yeah, exactly. I am trying to understand, like, are you saying, so what I understood with the understood, so just to clarify. So you said, or what I understood is that you were saying that the user needs to know all these technical concepts. And I'm wondering, what does a user mean there? Is it the user of Klave? And is it really realistic that a user of Klave will know all of these things? I mean, working more than 6 years, I have only a bit of background of confidential computing and somewhat formal verification, but so
Exactly.
Is it really realistic for a user to have expertise in all of them?
No, that's precisely the point. So the attestation process and actually, so we know that the potential is there, right? So confidential computing, if we open source everything that is running in the TV, then it is technically possible for someone to actually verify if they have the knowledge every single bit, so that they don't have to trust a secretary as a trusted party. But of course, it's not realistic to expect Klave users, even companies, to be able to understand all of this, to do it by themselves. And so that is where the last slide comes in. How then are users of confidential computing going to establish their trust in these systems. Because once you explain to a company or to a regular person who might be tech savvy, the potential of confidential computing, they understand that. But even if formal verifications were already, standardized and everybody was already doing them, even if I gave all of that evidence to a user, they would still come back to me and say, but I don't understand this. And so they still need, I believe, to trust someone or an entity or a group of experts, and they need to rely on them. But I think the big difference, between what we at Secretariat are trying to do is that even if it's not feasible for an individual user to verify everything by themselves, or even if the software is moving too fast to keep up, everything is still open, and in retrospective, you can still go and verify the honesty of the code that was played.
Okay, so any other questions?
What it was. Is your approach universally applicable? How about apps such as WeChat, Alipay, which are slightly different, and what you described wouldn't be enough or wouldn't be possible to establish correctness or attestate anything?
So Klave will run basically any code that can be compiled into WebAssembly, and that is kind of built against our SDK. So we're talking about specific applications there. Our approach in order to minimize the trusted computing base is that you extract the relevant bits of an existing application, the bits that you want to keep private, the ones that are processing the user's data, and you migrate them into the confidential computing space, as opposed to just lift and shift an existing application and then forget to do the attestation process altogether and just trust some golden values that are being delivered to the users, rather than keeping everything open source and clear, so that there's always that opportunity there, if these technical concepts are all there, for someone to verify the honesty of the code.
Okay, this may not always be possible, that's what the community is like.
Yes.